Sorry.
Okay, we'll show you some lichens in a minute.
Fungus.
And it's possible that these early lichens colonized the land surfaces and began to weather the rocks so much that they sent lots of phosphorus into the ocean. And phosphorus is a very rare element. And the algae and bacteria in the ocean took up the phosphorus. They photosynthesized hugely, and they took out so much carbon dioxide from the atmosphere that the Earth froze over. So this is when we have a snowball Earth. And we have about 4 of them between here and that wall, each lasting about a few million years. So,
any sense of how it gets out of it?
Yeah, the way you get out of it is through volcanoes, because volcanoes are constantly erupting CO2, and eventually it takes a long time, but eventually that warms the Earth up again. And every time, the other interesting thing is, every time we have a snowball Earth, we get more oxygen, because so much carbon is buried that more oxygen is released to the atmosphere. So now we have a warm period, and then now again more weathering, another snowball. There were about 4 of them till we get to about here. The last snowball Earth, round about here. So can you imagine a series of snowball Earths, the Earth freezing over completely and then thawing out, freezing, and the last one, round about here, it's possible that it was so harsh that the unicellular organisms had to come together to survive. They had to cooperate and form the first multicellular organisms. This is all very speculative. So round about now, because of a seeming catastrophe of this last snowball Earth, we get round about here, about 600 million years ago, sorry, about 540 million years ago, the first multicellular life. And in fact, if you look in the fossil record, around 540 million years, roughly here, you find fossilized multicellular organisms like worms, snails, trilobites, all over the planet in rocks of this age. It's a kind of explosion of multicellular